Hey, what's up, y'all? Thanks so much for joining me on today's video, where we're going to look at how we can use a little bit of simple trigonometry to or animate shapes in an orbital fashion, and then start to use those equations to kind of get a little bit of a primer on how we can use math to create some interesting visual forms. So we're going to write a really simple little polygon algorithm using the trigonometry that we're going to go over to animate things along a circle here. So to get started, we need to take a look at that math. So let's go ahead and do that. As long as we know the radius and the angle, we will be able to determine the x and y coordinates of any point along this circle, right? And the equations that we need to do that are x equals radius times cosine of theta, or the angle here, right? And y equals r times sine of theta, or this angle over here, right? So this is the only math that we're going to need to calculate any point on a circle. Not too difficult. Let's take a look at how we're going to do that in processing. Okay, we will say goodbye to our little examples. Let's go ahead and make a new sketch. Void setup and draw. Oops. Let's go ahead and make our canvas 640 by 480. And we'll color the background white, like so. And we know we're going to need a couple of variables already, right? We know we're going to need r. And we also know we're going to need an angle. Could name this theta if you want to, but I'll just keep it angle for simplicity's sake. Okay, and let's set those, let's initialize those here. Let's say I want the radius of the circle. I don't want to be quite half the height because I want there to be a little bit of breathing room on the upper and lower margins. So let's say the radius, we're going to set that equal to height times like 0.45, right? And then let's initialize our angle at 0. And let's give ourselves, let's just draw a circle so we can see what's going on. Draw a circle. So how about push matrix, pop matrix, translate to the center, and then we're going to draw an ellipse here. So we'll say ellipse, 0, 0, and we want this to be r times 2 because the ellipse is expecting the width and the height, which is really the diameter of a circle, right? Not the radius. Radius is just from the center of the circle to the outer edge. So radius times 2, radius times 2. And I think that should give us a nice looking circle right in the center of our screen. Cool. Okay. And now we need to plug in the math, these equations that we went over just a moment ago, so that we can start calculating points along this circle. So let's take a look here how we're going to do that. Point on the edge of the circle. So we also want to calculate an x and a y position. So let's give ourselves a couple of variables so we can do that. And we'll say x equals r times cosine of angle, right? And we'll say y equals r times sine of the angle. And then we'll do the same as we were for our previous circle here, push matrix and pop matrix. Let's translate this time to x and y that we've just calculated, right? With these equations here. And then we'll say ellipse 0, 0, how about 10 by 10? Let's see what we get. So I'm expecting it to kind of be over here on the right side of the circle where, oh, we're up here. Ah, okay, it's because we also want to, okay, we actually want to get to the middle. We would need to center that. Okay, so this puts us at the, this translates to the center, right? And then I'm calculating x and y, assuming that we're already in the middle, right? Um, so if you wanted to, you could, yeah, have a translate, maybe outside of these push matrix, pop matrices. But anyway, we needed to go to the center and then figure out how to get to that xy. Okay, so now we've got a point on the circle here, right, where the angle is equal to 0. This sine and cosine functions are expecting this angle in radians, and so if I want to change the value from 0, I either need to use the radians function, or I need to just like give it a value in radians, right? So if I'm thinking in degrees and I want to say rotate 360 degrees, right? Maybe I say angle equals radians 270 degrees, right? This is one way that I can move around the circle, right? So now I'm up here at 3 pi over 2, or I can just say, something in radians. I could say quarter pi, right? And that'll put it over here, right? So you can see now, as I'm changing the angle value, my radius is staying consistent, and it just calculates the x and the y position for me around the circle. Okay, so from here, we can animate that, or we could use our mouse. Maybe I say angle equals map mouse x, which I know goes from 0 to 640 between 0 and 2 times pi, right? Because that's going to be a full 360-degree rotation expressed in radians here. And so as I move my mouse and I increase that angle between 0 and 2 pi, I get all the way around the circle, which is super great. If I wanted to just animate it so that it does it on its own, I can say angle plus equals 0.001. And this will move fairly slowly. You can see it's kind of going. Maybe I want it to go a little faster. Let's go slightly faster than that. Okay, so now we've got this shape, this ellipse that we've drawn, this point moving around the circle. All right, so now that we have this working, let's go ahead and move on to how we're going to use these equations here to create a simple polygon algorithm, right? Creating a shape using math. Let's give ourselves a number of vertices, and let's start with a triangle. We'll set this equal to 3, and then we can comment this out for a minute, because what we want to do is actually calculate position of our vertices. And to do that, we're going to use a for loop. We'll say for int I equals 0, I is less than the number of verts, I plus plus, right? And what we want to do is we want to calculate the position of each, or the first thing we want to do is calculate the angle, right? So we'll say angle equals I divided by verts, right? And this is going to give us a fraction that we can use to multiply a full rotation, right? So we'll say 2 times pi, and we'll put this here, right? So 2 pi is basically like 360 degrees. That's a full rotation, right? And I divided by verts, right, will give us, let's take a look. First time it runs through the for loop, we're going to have 0 over, in this case, 3, right? So 0 divided by 3 is 0. So the angle will be 0, right? The second time this runs, I will be 1, and we'll have 1 over 3. So it'll give us 1/3 of a full rotation, right? So we're at 0, 1/3 of a full rotation. And then the last time this runs, I will be equal to 2, and so it'll be 2 over 3, so it'll be 2/3, right? And we multiply a full rotation by 2/3, and we get 2/3 of a full rotation, right? So then we can take this code, and stick it in here, where we're calculating the angle this way, and then we calculate our points X and Y position, and then we draw those points on the circle. Nice. Okay, so now we've got 3 points along the circle. And if I want 4 points, I can just come up here and say 4. Now I would have a shape with 4 points, right? I could say 5, right? And as you can see, as you increase your vertices, or this number verts, you'll get more vertices calculated, right? So now we're able to calculate all our vertices. Let's wrap this up into a P shape, right? Let's say P shape polygon. And what we can do is we can say polygon equals create shape. And we'll say, see, polygon dot begin shape and polygon dot end shape. And we will then add some vertices. So we'll say polygon dot vertex, right? And this is where we would need to populate all of the vertices, right? So let's move this code here in between our begin and end shape, right? Because we're going to want to use our for loop to add a bunch of these vertices, right? So instead of drawing an ellipse at each of these points, right, what we're going to do is add a vertex to our P shape at each of these points, right? And I think we should end up with, oh, of course I have to draw the shape. Duh. Okay. Might also need to translate this. Yeah, you can see it's all the way up there around the origin. So push matrix, pop matrix. Let's translate this to the middle of the screen. Okay, nice. Oh, and I want it to close the shape, so I need to come here and say close. Nice. Okay, and so now, right, I can control this algorithm like we were doing in the example. I could use, I can increase and decrease the number of vertices, right? So I can say verts equals, let's cast this as an int so we don't ever have any in-between numbers, right? Actually, I want to round it, I think, because I don't want it to be an integer. I need it to be a floating point number so that when I do this math here, it does give me actual, like, decimal place numbers, right? Because it's going to say 1 over 3 needs to be 0.333. So I still need this to be a floating point number, right? But I'm going to round a mapping, right, of mouse x, which I know goes between 0 and 640, right? And let's say I want the smallest shape to be a triangle with 3 vertices, and the largest shape, I think in the example, was 8 vertices. I think that should work. Let's take a look for an octagon here. So we have a triangle, and yes, as I move my mouse left and right, I'm increasing and decreasing the number of vertices. Okay, so I think that we've accomplished everything we set out to do in this video. So hopefully this has kind of whet your appetite for using some math to generate forms. And you can take these specific equations here that we use today to animate anything that you'd like in an orbital fashion. See you next time.